to material science. In this experiment, I will explain about introduction, learning outcomes, and additional theory.
My name is Muhammad Sajjad Rahmat and my number metric is AA190 and today I will explain to you about objective, apparatus and observation for this experiment.
Assalamualaikum and hi, my name is Muhammad Haikal bin Abdul Rahman, matrix number AA190872 from section 2 material science. For this experiment, I will explain about procedure and result.
Assalamualaikum and hello, my name is Muhammad Hafizuddin Binodin. My number metric is AA191510 and today I will explain to you guys about discussion and conclusion.
So this is the introduction for the impact test. So the impact test can be used to determine the change in the temperature range from ductile to brittle nature of a polymer when the temperature is lower. This test also gives information on the strength of a material when subjected to a load in a sudden. The objective of this experiment is to examine the effects on the material fracture toughness using the standard ISOT impact test. At the end of this experiment, we will identify the impact of a substance and calculate the energy and the impact of strength. This is the additional theory for this experiment. The toughness of a material changes significantly by varying its thickness or varying their geometry. Secondly, the notches and the shape of the notches influence the toughness of the material. For the ISOT impact test, the sample is positioned in the vertical cantilevered position. Only the bottom end of it gets locked. The difference between the two methods is in the manner that the specimen being held, clamped at its lower end in the ISOT. The range of 10 to 20% fiber loading is suggested for the mostly applied in short fiber natural composites.
Today, I will explain to you about the objective, apparatus and the observation for this experiment, which is experiment 3. So, what is the objective? We have four objectives that we can find, which is first, to determine the amount of energy absorbed by a material during a fracture. Second, to investigate the influence of the notch shape or the notch bar impact. Third, to be able to calculate the impact energy and impact of strength. Lastly, we can determine the material behavior at higher deformation speeds. So next we go to the apparatus. So what apparatus that we use to conduct this experiment? So as you can see on the diagram, we use standard impact testing apparatus. So what is standard impact testing apparatus? Standard impact testing apparatus is a apparatus that we use in studying the toughness of a material. A material toughness is a factor of its ability to absorb energy during plastic deformation. Brittle materials have low toughness as a result of the small amount of plastic deformation that they can endure. We can see some of the observations, which is first, the pendulum impact test involves the measurement of the energy required to break the test specimen that clamp at the ends and then strike in the center by pendulum wave. Second, based on table, we could see that the fracture area is 40 mm square. Third, energy that required to break the specimen can be determined by calculating the energy loss in the pendulum. Fourth, while the toughness is a measure of energy that can be absorbed by the material before fracture. Next, the absorbed energy by specimen that we obtain is 0.322 kilojoules. Lastly, this energy and impact strength can also be determined by using this formula, which is impact energy equals to weight times height. Next, weight or impact force is equal to mass, which is kilogram, times with acceleration of gravity. And lastly, we can also find impact strength, which is absorbed energy divided by fracture area.
My name is Mama Aikal. I will explain about the procedure. Firstly, by using the notching machine, cut a V notch at 45 degree depth at the middle of the specimen, which is in the room temperature. Next, rise up the pendulum at an angle 150 degree and lock it for safety purpose. Then, by facing the notch as shown in figure, mount on the specimen on the anvil. Release the pendulum and it will hit the center. Then, by using the braking system, the pendulum will be slapped after the specimen is broken. Next, observe the scale reading shows the effect of energy. Then, fracture surface is obtained afterwards. Then, replace another specimen and mount on for a moment before using different temperatures. Next, repeat step 3, step 5, step 6, step 7 and step 8 again. Now I will explain the result of the experiment. Type of specimen that we are using is polymer. From the result, the length of fracture is 5.00 mm. The width of the specimen is 8.00 mm. And then the fracture we got is 40.00 mm square. After that, the impact energy of specimen is 321.99 joule. The absorbed energy is 0.32 kilojoule. The fracture area in meters square is 0.04 meters square. And lastly, the impact stress of the specimen is 8.05 kilojoule or meter square.
Hello, my name is Muhammad Hafizuddin bin Nurdin, and now I will explain about discussion for experiment impact test. There are several factors that affect the impact energy of specimen, which is yield strength and ductility, notches, temperature and strain rate, and fracture mechanism. If the yield strength are increased, we could see the impact energy decrease. If the material undergoes some process such as cold working or precipitation hardening that makes it more brittle and less able to undergo plastic deformation. Meanwhile, the notch act as a tension focus and some material are more sensitive for notches than others. Therefore, the notch depth and tip radius are very important. Other than that, the temperature and strain rate affecting the impact energy because the majority of the energy of impact is consumed during the yielding by plastic deformation. For fracture mechanism, it involves to the plastic deformation that hence absorb the fracture energy. Some material like carbon steel are the subject of so-called ductile to brittle transition. Next, this impact test used to determine the material capability to absorb energy during collision or impact. This energy usually used to determine impact strength, fracture resistance, and toughness of material that depend on the test and characteristic that needed. These values are important for selection of material that need to handle certain energy well. For example, the car may got hit by a truck or another car. The material to build a car need to make sure it is strong enough to keep the driver safe. Last but not least, some metals which are ductile at room temperature become fragile at lower temperature. This is called a ductile to brittle transition. The ductile to broken temperature of the transition depends on the metal composition. Steel is a metal that shows this behavior most frequently. Tests being carried out over a range of temperature given S-shaped curves. It is traditional measures when breaking a notch bar in a pendulum type impact tester and measuring the energy absorbed in the fracture. The transition temperature may be about 0 Celsius for some steels and can be below 0.2 Celsius in winter in some part of the world. As a result, in winter some steel system most likely collapse. At the end of this test, we know that impact tests are used to measure the material hardness. We have shown how the material's ductility changes by temperature, which shows that the material at high temperature is more ductile, while at low temperature material more brittle. We could infer that this experiment is influenced by the yield strength and ductility, notches, temperature and strain rate and fracture mechanism. Repeating this experiment step are recommended to get more accurate data. This is our reference for this experiment, and thank you for watching our video.